Hello everyone. Today we're going to talk about Azure Functions using the PowerShell runtime. So this session is delivered as part of the Azure Back to School event. So Azure Back to School is an annual community event featuring IT professionals from across the world. Community members submit sessions, either videos, blog articles, pretty much any medium, to provide viewers with actionable knowledge. The event takes place every September from the 1st of September to the 30th of September. So you can find this session and many other awesome community sessions at azureBackToSchool.com. So let's start delving into talking about Azure Functions using PowerShell. So let's get into an introduction. So my name is Luke Murray. I'm a senior consultant at Datacom in New Zealand, as well as a proud Microsoft Azure MVP from Hamilton. Over the years, I've had the privilege of working closely with Azure and helping businesses unlock the potential of cloud technologies. Today, I'm excited to share some of the insights I've gained throughout my journey, and I hope this session will provide valuable knowledge and inspiration to help navigate your own path in cloud infrastructure and Azure solutions. Feel free to connect with me on social media, such as my website, LinkedIn, GitHub, and reach out if you've got any questions. So today we're going to have a rundown on Azure Functions with PowerShell from concepts through to create and deploying our first function into Microsoft Azure. To do this, I've split the video into 6 separate sections, covering elements that are both practical and theoretical. So let us get started. The first introduction the first part is an introduction where we're just going to discuss where Azure Functions sits in the overall Azure ecosystem and benefits of using Azure Functions with PowerShell. We'll also run through creating our own Azure function and dive into the detail around the PowerShell runtime capabilities with the Azure Functions. Then we'll run through deploying our function to Azure. But first, we'll need to configure our development environment to help deliver our PowerShell-based Azure functions. And finally, I will end with a conclusion of what we have achieved and where you can access more resources to help further your learning. So let's go into an introduction and overview of what Azure Functions are, their role in serverless computing, and why use PowerShell with Azure Functions. So we're going to go through some of the benefits of using PowerShell for Azure Functions, with such as scripting capability and integration into other Microsoft Azure services. So Azure Functions is a core part of the Microsoft Azure Cloud Platform, offering serverless computing capabilities that allow developers to build and deploy applications without managing the underlying infrastructure. Serverless computing means that resources are allocated dynamically, allowing for rapid scaling based on demand. In the Azure ecosystem, Azure Functions sit at the heart of various services and integrations. It's designed to execute small pieces of code such as HTTP requests or timers or messages from other Azure services, such as Azure Service Bus, Event Hubs, or storage queues, which is what we're going to be demoing today. This event-driven nature of Azure Functions makes it an ideal fit for tasks such as automation, data processing, and real-time processing. Azure Functions supports multiple languages. This includes C#, JavaScript, PowerShell, Python, making it versatile for different development needs. Additionally, it integrates smoothly with other Azure services, enhancing its utility in larger systems. For example, Azure Functions can be used in conjunction with Logic Apps for workload automation, or it can trigger and be triggered by services such as Azure Cosmos DB, Azure Event Grid, and Azure Monitor. So Azure Functions operates on a serverless architecture. This means that developers need to focus entirely on running the code without worrying about managing their underlying infrastructure services or servers. Azure Azure automatically handles the scaling, provisioning, and maintenance, freeing up time and resources for the development teams. Another major feature is event-driven execution, which we've sort of touched on earlier. Functions are triggered in response to various events, such as HTTP requests, timers, or changes in data and storage. This makes Azure Functions ideal for creating responsive, real-time applications that react to specific inputs or events across the Azure ecosystem. From a business perspective, cost efficiency is a key benefit. Azure Functions operates on a pay-as-you-go model, so organizations not only pay for the compute power consumed during function execution, which eliminates the cost of having to pay for resources that are idle, making it a more affordable option for handling variable workloads. In terms of scalability, Azure Functions automatically scales to meet that demand. As traffic or events or the event volume increases or decreases, additional resources are dynamically allocated, ensuring that your application can handle spikes in activity without manual intervention. Finally, language support makes Azure Functions very versatile. It supports a wider range of programming languages from C Sharp, JavaScript, Python, and of course PowerShell, allowing developers to use their preferred language for building cloud-based solutions. These features combined make Azure Functions a flexible, cost-efficient, and highly scalable solution for building event-driven applications in the cloud. By leveraging PowerShell within Azure Functions, developers and IT professionals can create robust, automated solutions that integrate seamlessly with Azure services, enhancing productivity and operational efficiency. Firstly, PowerShell provides deep integration with Azure services through a comprehensive set of commandlets. These commandlets allow users to interact directly with Azure resources, enabling developers and administrators to automate complex tasks like managing virtual machines, storage accounts, and networks. This makes PowerShell an excellent choice for those looking to enhance efficiency in Azure-based operations. Next, automation capabilities are a core strength of PowerShell. With its scripting functionality, repetitive tasks can be automated, significantly reducing manual effort and the risk of human error. This is especially valuable for routine operations like provisioning resources, managing configurations, and performing operational tasks, leading to time saving and higher productivity. Additionally, PowerShell enjoys strong community and support. It has a large active community of developers, administrators, and users who contribute extensive documentation, modules, and examples. This makes PowerShell easy to learn and implement, with a wide variety of resources available to help teams create automation scripts and solutions tailored to their specific needs. Finally, PowerShell's ease of use is worth noting. Its straightforward syntax, combined with its powerful scripting capabilities, make it a preferred tool for administrators and IT professionals, allowing them to quickly develop scripts and automate a wide range of tasks in Azure, improving both operational efficiency and system reliability. In summary, PowerShell with Azure Functions empowers teams to automate tasks efficiently, manage Azure environments seamlessly, and harness the power of community-driven support and resources, making it an essential tool for anyone working within the Azure ecosystem. If you're discussing Azure Functions with PowerShell, you may be asking, so Azure Functions or Azure Automation? As usual, it depends. There's some trade-offs to consider here. My personal rule of thumb is for IT operations such as start, stop VM, or needing to run tasks on premises onto on-premises workloads, go Azure Automation. For more business-oriented processes and complex tasks, Azure Functions. But let's get into that a bit more. So we're going to dive into a comparison between Azure Functions with PowerShell and Azure Automation with powerful PowerShell runbooks. Both of these tools are powerful in their own right. offering distinct advantages depending on the task at hand. Let's start by discussing the purposes of each. So Azure Functions with PowerShell is designed for event-driven serverless computing tasks. It excels in handling quick, event-based automation, such as responding to Azure Monitor alerts or processing data from Event Grid. On the other hand, Azure Automation focuses on process automation, configuration management, and update management across Azure and on-premises environment. This makes it ideal for those more management type workflows. Now let's look at the execution model between them. Azure Functions is trigger-based, executing based on events such as HTTP requests, timers, or events from other sources like Event Grid. This makes it great for on-demand, lightweight tasks. In contrast, Azure Automation operates on a scheduled or on-demand basis through runbooks and schedules. These runbooks can be triggered manually or via webhooks, making it ideal for those recurring processes. When we talk about integration, this is where Azure Functions truly shines. Azure Functions is natively integrated with a wide variety of event-driven services within Azure, such as Event Grid, Azure Storage, and Service Bus, allowing it to really respond quickly to those real-time events. This makes an excellent choice for scenarios where automation must happen instantly in response to those specific triggers. On the other hand, Azure Automation provides extensive integration into Azure services as well, but it's more focused around scheduled tasks and on-demand automation, which are perfect for those repetitive processes, configuration management, and system updates. Regarding language support, both Azure Functions and Azure Automation support PowerShell, but Azure Automation also supports PowerShell workflow, which offers greater flexibility if you need to build those complex automation scripts. But now let's examine some use cases. So Azure Functions is great for those lightweight, event-driven tasks, such as responding to real-time alerts or business performing ad hoc operations based on the triggers. In contrast, Azure Automation is really the go-to solution around configuration management and management tasks across hybrid environments. The development tools for both Azure Automation and Azure Functions are very similar, where you can get Azure Functions, VS Code, Visual Studio Code extension, and the same thing for Azure Automation as well. So to sum it up, both these solutions have their place in the Azure ecosystem. Use Azure Functions with PowerShell based on when you need fast, event-driven automation, and go for Azure Automation when you need to automate those complex workflows and manage resources across hybrid environments. But again, it depends. Like I said, my general personal rule of thumb is for IT operations such as start, stop VMs, go Azure Automation. But for more business-orientated processes and tasks, go Azure Functions. But there's no issue with starting with one and then moving to another as your needs develop. So in this section, we're going to discuss a bit more about the Azure Functions architecture and how Azure Functions actually operates in a serverless environment. We're also going to discuss a bit more about the PowerShell runtime and how it works with Azure Functions, including supported versions and any specific considerations that we may have with that. We're also going to discuss triggers and bindings and how they work with PowerShell scripts. So Azure Functions is one of the core services within the Azure ecosystem that has revolutionized how we approach serverless computing and event-driven automation. To start, Azure Function is a serverless compute service that allows you to run event-driven code without having to manage the underlying infrastructure. Let me unpack that for a bit. Traditionally, when building and deploying applications, you've had to manage the server, storage, and compute resources needed to host your code. But with Azure Functions, Microsoft takes care of the infrastructure for you, so you can focus just on the code that matters the most to your business. So in essence, it lets you respond to specific events such as HTTP request, a new file in the storage account, or a timer trigger without having to worry about the operational overhead of maintaining the servers. The beauty of Azure Functions lies in its event-driven model. What does that mean? So imagine the code executing automatically in response to various types of events. It could be triggered by an incoming web request, a message on a service bus, or even a change in a database. You can build real-time solutions like automating workflow processing of IoT data streams or handling messages in a microservices architecture, all with minimal effort. Now let's talk about some of its key benefits. Scalability. Azure Functions can automatically scale to meet demand. Whether you need to handle one event or millions, it will scale dynamically to ensure performance without manual intervention. Cost efficiency. Because it's serverless, you only pay for the execution time of your functions, not for the idle time. This pay per execution model is perfect for workloads that are variable or sporadic. Multi-language support. Azure Functions supports a variety of programming languages, including PowerShell, C Sharp, JavaScript, or Python, and more. This flexibility allows developers to use the language that best suits their project needs. Integrations. Azure Functions seamlessly integrates with Azure services like Event Grid, Service Bus, Azure Storage, and Azure Logic Apps. This tight integration makes it easy to automate tasks and orchestrate complex workflows. To give you an example, imagine a scenario where a new file is uploaded to an Azure Storage account. Azure Functions then automatically triggers a function that processes that file, logs information about it, and sends a notification. All this happens in real time without any need for you to manage the infrastructure behind it. So, the Azure Functions programming model is key to understanding how Azure Functions works and interacts with other Azure services. So let's break it down into three components: events and triggers. So Azure Function is an event-driven, meaning it reacts to various types of events or triggers. These events could come from timers, HTTP requests, or other Azure services, as mentioned earlier, like Event Grid or Service Bus. Essentially, when one of these events occur, it automatically triggers the corresponding Azure function. The second part of it is the code. So after the event triggers the function, the core logical code then executes. You can author your functions in several languages, as we discussed earlier, making it very flexible for developers to use the language that they're most comfortable with and suited for the job. Finally, outputs. Once a function has executed, it can send results or outputs to various destinations, whether it's sending data to a database, triggering notifications, or interacting with another Azure service. The function can easily integrate with an ever-growing collection of services to take further action. In essence, Azure Functions allows you to connect events, write code, and produce meaningful outputs, automating workflows and processes in a serverless way. It's simple, yet highly scalable, and you only pay for what you use. So let's go into a bit more about the architecture and how Azure Function Apps work. I wanted to give you a bit more information on the high-level concepts of Azure Functions so you know when you're developing and working with your functions, essentially what is happening and which part of the process is being triggered. So let's go back to event sources. So these are the various inputs or triggers that initiate the execution of a function. Event sources can include HTTP requests, timers, Azure Storage queues, Service Bus messages, or any other event sources supported by Azure Functions. Then you've got your scale controller. So the scale controller monitors the incoming requests and determines if more function instances are needed based on their number of events and the current usage. It plays a critical role in scaling the application dynamically. The scale controller continuously monitors for events that are coming from the various sources. It also keeps an eye on the resource usage of existing function instances to determine if additional instances need to be created or destroyed. Finally, we've got our function instances. These are the actual environments that we're running your function code. Each instance is allocated a certain amount of resources, such as 1.5 gigabyte of RAM and 1 CPU in an example. When the scale controller detects that more capacity is needed, based on the event load and current usage, it creates a new function instance to handle that additional workload. Each function instance can handle multiple invocations of functions, meaning it can run your function code multiple times for different events in parallel, depending on the resources available. Now, let's go into the invocation. So this represents each execution of a function, which is triggered by an event. Multiple invocations can occur on a single function instance, provided there are enough resources. Overall, the Azure Functions architecture enables automatic scaling based on the demand, providing a flexible and cost-efficient way to run workloads without the need for constant infrastructure management. So what about PowerShell? And how does this fit into the overall function infrastructure? So PowerShell functions can be triggered by various event sources, such as HTTP requests, timers, messages in Azure Storage Queue, Service Bus, among others. This is no different from a regular function. It still can be event-driven model based on those same triggers. You can define the trigger in the functions.json file that's associated with the PowerShell script, which tells Azure Functions when to execute your PowerShell function. For example, a timer trigger might be run at the function at specific intervals, while a HTTP trigger would run the function upon receiving a HTTP request. The scale controller monitors the incoming events from the triggers. When using the PowerShell runtime, the scale controller doesn't change its behavior at all. It still watches for the number of incoming events and load based on existing instances. With PowerShell functions like other Azure functions, this will scale up to multiple instances if the demand increases. The scale controller determines when to spin up or down additional function instances based on metrics like the rate of incoming events or CPU and memory usage. When an event triggers a PowerShell function, Azure Functions spins up a function instance that has the PowerShell runtime environment. This instance includes all the necessary PowerShell modules and Azure Functions runtime needed to execute the PowerShell script. Each function instance can handle multiple invocations, meaning it can run the PowerShell script multiple times for different events. Each invocation is isolated, ensuring that the scripts can run independently of each other, even within the same instance. Each function instance typically has a set amount of CPU and memory resources allocated, and PowerShell scripts should be optimized to run efficiently within these resource constraints. So when an event triggers the function, the PowerShell script associated with the function is then executed. The script can use the PowerShell commands and modules to perform tasks like managing Azure resources, sending emails, or querying databases, etc. PowerShell functions can also use input and output bindings defined in the function.json file. For example, a HTTP trigger might read data from a request body, which is the input binding, and then send a response back, which is the output binding. The PowerShell script accesses these bindings using a predefined variable like $reg for requests or $res for responses. PowerShell functions can include error handling, like try-catch blocks, and can log information to Azure Application Insights or the console for debugging and monitoring purposes. The controller automatically scales based on the number of PowerShell function instances needed. If more events are coming from a single instance that it can handle, Azure Functions will then automatically create more instances with the PowerShell runtime to help balance that load. Once the load decreases, Azure Functions will scale down the number of instances, stopping those that are no longer needed to save on costs and resource utilization. Using PowerShell and Azure Functions allows you to leverage your existing PowerShell scripts and knowledge in a serverless environment. The PowerShell runtime integrates seamlessly into Azure Functions' scalable architecture, which automatically allows you to manage resources and scaling based on demand, just like any other supported runtime. This flexibility enables you to run automation tasks, manage Azure resources, and perform administrative tasks in a serverless, event-driven model without worrying about the underlying infrastructure management. So all functions in a function app must share the same language. You can choose the language of the functions in your function app when you create the app. The language of the functions is maintained in the functions underscore worker underscore runtime environment variable and can't be changed when there are existing functions that are using the function app. By default, function apps are created in the Azure portal or by the Azure CLI or from Visual Studio Code are set to use version 4.0. You can modify this version if needed. You can only downgrade the function runtime to like 1 times after you create your function app, but before you add any other functions. Updating to a later major version is allowed even when apps have existing function. So there's a difference between the function runtime and the PowerShell version it supports as well. So when I'm talking about version 4 point something, I can't remember the exact minor version number at the moment, but that's the latest function runtime. The PowerShell runtime version is 7.2, and of today of this recording, 7.4 is now generally available as well. So there are differences in the function runtime version and the PowerShell version runtime version as well. So Azure Function apps have specific timeout durations depending on the hosting plan. The function timeout property in the host.json file controls the timeout for function execution. Here's a breakdown of some of the default and maximum values for different plans. So when you're talking about consumption plan, the default timeout is 5 minutes with a maximum of 10 minutes. When you're talking about fixed consumption, the default is 30 minutes with an unlimited maximum, although the execution could be terminated due to platform constraints. When you're talking about premium and dedicated plans, both have a default of 30 minutes and can be set to unlimited. Note that for the premium plan, up to 60 minutes is guaranteed for OS and runtime updates. When you're running Azure Functions with a container app, the default is 30 minutes with an unlimited maximum when the minimum number of replicas is set to 0. Additionally, for HTTP triggered functions, the Azure Load Balancer, which is handling the requests coming into your function apps, imposes a 230-second response time limit. For longer running processes, consider using durable functions, asynchronous pattern, or deferring any actual work to respond immediately. We're not going to be talking about durable functions today, but for those long-running tasks or processes where you might have one function doing something else, passing it on to doing another thing, that's where durable functions really come into play. There's an extension on really processing from point A to point B. Very, very heavily useful and very powerful, but we're not going to be talking about that today. A PowerShell Azure function is represented as a PowerShell script that executes when triggered Each function script has a related JSON function.json file that defines how the function behaves, such as how it's triggered, and its input and output parameters. Like other kinds of functions, PowerShell script functions takes in parameters that match the names of all the input bindings, which is defined in the functions.json file. A trigger metadata parameter is also passed that contains additional information on the trigger that started that function. So let's go in a bit more about triggers and bindings. I've talked a bit about them, but what exactly are them and how do they work together? So a trigger defines how the function is invoked. Each function must have exactly one trigger. Triggers have associated data, which is often provided at the payload of the function. For example, HTTP trigger invokes the function via a HTTP request. A timer trigger invokes the function based on a schedule. A queue trigger invokes the function when a new message is added to a queue. Bindings are a way to declaratively connect another resource to the function. These can be input bindings, output bindings, or both. Bindings are optional, and a function might have one or multiple input or output bindings. For example, an input binding provides data to the function, such as reading a message from a queue. An output binding sends data from the function, such as writing a message to a queue. In PowerShell, Azure Functions, the function script is represented as a PowerShell script that executes when triggered. Each function script has a related JSON function.json file that defines how the function behaves, such as how it's triggered and its input and output. So now we're going to go about setting up our development environment. So we're going to need a list of prereqs, such as you're going to need access to an Azure environment, you're going to need access to Visual Studio Code, we're going to need access to the Azure Functions extension. And in this example, I'm going to go through the demo with my environment already set up using a GitHub code spaces that's running the PowerShell 7.2 runtime. And we also have the Azure Functions core tools installed, which allows me to test development on my function locally without ever needing to connect it to Azure. And we're going to run through testing a HTTP request normally in this environment. So you can go and completely set up your own local environment using Visual Studio Code and installing the function apps, or you can use the code space that I've developed as well. I'll put the link to the GitHub repository in the comments of this video. So just to recap, we're going to need Visual Studio Code, we're going to need the Azure Functions extension for VS Code, and of course a Microsoft Azure account where you have the permissions in order to connect. So we're going to use Visual Studio Code in my examples, but you can use Maven, you can also just use Visual Studio. The tools that are very useful to have when developing Azure Functions are Azure CLI and the core tools, which allow you to do the development locally, which essentially emulates the Azure Function runtime, which is going to be installed in the code space that I'm using. And of course, you need PowerShell installed. So PowerShell 7.2 or 7.4, which is actually not in preview as of today. So that's now generally available as well. So any new functions you develop should be on 7.2. So let's get into the demo. And yeah, I'm going to show you the code space, Azure Functions, the PowerShell version, which I will be using 7.2 because that's what I already had set up. But 7.4 only went GA today. We're going to be using the code space on a .NET 1.6 space image, and Docker Compose with Azurite as a storage emulator has been installed as well. But I'm going to go through, so let's take a look at that. So here we have my GitHub repository that I'm using for developing my Azure functions. So for PowerShell, so I've got a couple of example functions here already and a REST book, including the host and the profile. So let's open up a code space. So code, create code space on main. This will take a couple of minutes just for the code space to create. And then once it's fully up and running, we'll get into actually going through how it is and testing a HTTP trigger locally, as in locally in the code space. However, this could also be your own workstation as long as you've got the core tools installed for Azure Functions. So here we have our code space, and we've got a README that I've created, just explaining how to start the core tools for the function app. And we've got a demo as well that we'll go into in the second part after we actually deploy a function into Azure. But so we've got our environment here, we've got our README, we've got our dev container. So I'm just going to walk through some of the dev container first. So the dev container is essentially the code space that I'm running. So this Visual Studio instance is actually in a Docker container delivered and served up to me from GitHub. We can see here we've got the ports. So these are the ports that are available. So for example, 7071 is our function port that we'll be using. So if we open that up, it shouldn't connect to anything because we haven't got the function runtime working there at the moment. But then we've got our normal other ports, so 10,000, 10,001, 10,002 as well. So if we've got our ports here, if we go into the dev container.json file, this is really the meat of what makes it go. Then I'll tell you about what I've got in my current setup. So we've got the name of the dev container. So that's just an arbitrary name of Azure Functions PowerShell. It could be anything that you want it to be, but just be very descriptive. We've got a Docker Compose file. So that's bringing in a third-party Docker image on that supplements the code space that we already have here. So this Docker Compose file is primarily around the use of Azurite. So if we go into that, we can see that it's calling the Azurite Docker image or container from the Microsoft registry, and then allowing us to essentially bring it into this environment as well. So we can do some local Azure storage emulation within the code space. You don't need Azurite unless you're doing anything with Azure storage accounts directly. But in this case, I want an environment where I could develop my Azure functions using PowerShell locally as much as I can and test it without actually needing to go into Azure to deploy the functions as well and make sure it's fully working. This means that if you've got multiple people using or developing Azure functions, you can essentially use it in the space, and then you can use something like CI/CD, so continuous integration, continuous deployment, to merge your changes into main as well without impacting production. But in this example, this is just a demo environment that I used to develop my functions because I didn't want anything installed locally. So in this case, I'm using a GitHub code space to really emulate this. So we've got our Azurite, we've got our service, our workspace service. So that's essentially the name of the folder or the workspace we're going to be running. The ports that, as you can see here, that are forwarded from the container that's running out to externally to the internet. The visibility is private. You can change these to public as well. So you can actually use GitHub code spaces to run a website, for example, on port 80, and other people can view that as well. We're bringing in a couple of features, so essentially some packages. So in this example, it's PowerShell version 7.2. Now I've just alluded to, as of a couple of hours ago, before I recorded this video, 7.4 is now GA. So that's a PowerShell runtime version that I was telling you about. So when you're going to deploy any new functions, make sure you're using the latest version. So in this example, it's going to be 7.4, but because it only went GA, um, yeah, an hour or so ago, and I'd already got this environment set up for 7.2, we're just going to be going 7.2 today, but there should be really no change if I'm deploying this to a 7.4 environment. I also believe 7.2 is going out of support in about 2 months' time anyway, so I will actually, even though I will make this repository public, so you can come in and fork the repo and also copy and see for yourself how this GitHub code space is set up. I'll go in and update the version and do some testing as well. So don't be surprised if you see the versions update, because I'll update it to the latest version. Then we have our integrated terminal. So these are more customized. Oh, and I've got the Azure CLI installed, so I can do AZ login as an example, and the function call tools installed as well, which actually that's the core part of this. It allows us to develop our Azure functions locally. So keep in mind that for the purposes of this video, we're talking about PowerShell, but these features like the core tools, the code space could be adapted to any other language, for example, C# or Python. We just need the right runtimes installed in order to really use it. And then we've got so these are the Visual Studio Code customizations. So we've got our PowerShell as a default terminal. So if we go to terminal here, we can see a list of terminals that is built into the code space. We've got our PowerShell, we've got our Bash, our Cloud Shell, Bash, JavaScript, and Z. I think that's just that's just a normal sort of bash prompt. But as you may have noticed, when it opened it up, it went straight to the PowerShell prompt. So that's really the settings that's telling VS Code. Actually, the default profile for you, if you're running it on Linux, which is what this code space is using, then go to the PowerShell command terminal as a default. And then we've got our extensions. So the Visual Studio Code instance that's running, we could actually go and install these extensions manually as we normally would by clicking on extensions and install. But in this case, we want the Azure Functions extension installed. We want the PowerShell extension, and we've got a REST book that I'll run through as well, extension installed. So these are part of the code space. So as soon as the code space gets created and you're given the Visual Studio Code UI, those extensions are installed as part of it. And essentially our Docker file that this is running on. So this is actually the .NET 1.6 bookworm image that we're using from the Microsoft registry, and then the dev containers is the configuration. Dev container.json file is the configuration on top of that, and that's what's also calling the Azure installed. And then we've got our functions. So I've got two functions here. The create RG function, and that's going to be part of the next demo where we actually deploy our function and test it into Azure. So I'll go more into that on the next section. But what we're doing here is we're really just creating a queue from where we have an input from an Azure storage queue that we're going to be passing in some JSON file. And then the Azure function will actually create a storage account and a resource group within Azure based on the storage account queue. So it will respond on that. But that's for our next demo. For the demo we've got now, we've got our HTTP trigger. So I talked to you about how we could have an Azure function respond based on the different triggers. So in this example, it's a HTTP trigger. So we're going to send it a request, and then it's going to like a request. So we're going to give it a request, and then the request body will come back with information on essentially the parameter, and we're going to give it a name, and then it will output. So this is the output binding. It will output the body response as well, which will be hello, the name that we give it. This HTTP trigger executed successfully. So very simple example, but we're going to be doing this locally within the code space using the PowerShell, using the Azure Functions call tools. And then we've got our function ignore file. So don't really go into explain this anywhere else. However, the function ignore file is part of when you would look at deploying to a function app within Azure as an example. You might be developing this locally. So for example, I've got my REST book here. We don't want to push that file from our Git repo or the folder that we're working on into the function app. We don't want any files that essentially we don't need to be pushed into the function app. It's exactly the same as a .git ignore file as well. Sometimes you might be working locally and you might have your secrets stored locally, and you don't want to push those in plain text up into a public Git repository as an example. So you'd have a git ignore file to prevent that. In fact, it's right here. So you don't want to pass things like your app settings.json file and local settings as an example. And then we've got our host file. So this file is essentially the runtime extension version of the function app that we're using. So we're going to be using a version that's 4.0, so essentially the latest version, but between 4 and 5. So for example, if Azure Function Extension 5 was released, we'd still be using version 4, essentially the latest version at the time of the deployment. Managed dependency here is very useful, especially when we're talking about Azure Functions with PowerShell, because the managed dependency essentially is telling the Azure Functions, yes, we want you to manage our dependencies for us. So what I mean by that is we want it to be able to talk to the PowerShell gallery as an example in order to bring that information in. And to get to there, like here is the requirements. So when you're working with Azure Functions with PowerShell, you may want to be using certain modules. So in this example, we've got AZ accounts, AZ storage, and AZ resources. So these modules are required for the demo that I was talking about earlier, where we have our Azure storage account queue, and we're going to feed some JSON into that and then have the function app trigger based on that. But in order for the function app to connect to Azure, create the resource group, and create the storage account, we need to be able to call the PowerShell modules in order to do that. So to do that, we're using the requirements.psd1 file, and we're adding in the specific modules that we need. So the latest version of az.accounts, which is 2.0, 5 for Azure Storage, and then 6, of course, for az.resources. So when we specified the managed dependency within the host.json file, that's really what we're telling it to. We want Azure Functions in order to manage the dependencies for us. Otherwise, another practice would be to actually install the modules locally within, for example, this code space or your local computer, and then save it. So you can do an export module, you can save it, and then you can actually use the module within your function. So an example of where you would actually move the module files themselves into the function and then call that, instead of going and grabbing the version from the PowerShell gallery. There are a couple of reasons why you might consider that. One is the PowerShell module may be unavailable. And so when you do your deployment, it's going to fail because it won't be able to retrieve those modules. Another example is there could be a potential breaking change that occurred. You want to know that your PowerShell will operate on the exact same module version as an example. I mean, in this case, we're being very open, and we're just going to go, just grab the latest version of, the AZ accounts 2.0, and in between, 2.6 or 2.7, for example, there could be changes there. We're being pretty open with that, but we could actually remove the wildcard and just have it 2.6, an example, and hard code it to that version. But there might be changes where you might just want to store those modules locally as well. It can reduce the amount of hops that the function app takes in order to download those modules because you're storing it locally. There also may be times where you might be referencing a module that you've created or you've modified. You don't want that to go out and grab it from the public repository as well. So I just want to quickly go through, just checking my notes. So we've talked about the host.json file here. So this contains the global configuration options that affect all functions within the function app. So it includes the settings for logging, your extension, bundles, managed dependencies, and concurrency as well. So this is where you control it from a host perspective. So any files that are running in the host.json, any configuration that you've got in your host.json actually can affect multiple functions within your function app. Then you've got your local settings, which is potentially not here because I think I saw it in my git ignore. So yes, complete failure on my part, but essentially what that is you can create a local .settings.json file, and that is used to store your application settings, your connection strings, and other settings that you might be developing locally used by your function app when running locally. And it's not deployed to Azure, and it's not deployed because essentially you're not doing that. So in this example, I actually had a lot of the configuration for the in here as an example, I had things like the resource group name, the storage group name, the URL, I think the queue settings as well in my local.settings.json file when I was doing my development. But a complete misstep for me because it's gone because it was not committed to Git. So just keep that in mind. If you're developing this stuff locally within VS Code without using a code space, it's probably not as big of a deal because you actually still got those files locally. But in this example, I'm developing entirely from the dev container. And then you've got your profile.ps1 file. So just like you would have on a normal computer, like a workstation endpoint, the profile.ps1 file is executed every time your function app has a cold start. It can be used to define helper functions, run commands, or environment variables. The profile.ps1 file also includes code to authenticate with Azure PowerShell using the managed service identity. So every time you're essentially spinning up that run space, the function instance, the profile.ps1 is executed exactly the same as when you would be opening up a PowerShell terminal on your local device. You're also calling your profile.ps1 as well. So this is where you can make customizations and that you may want to be consistent throughout every single run. In this example, I've got it pretty basic. All I'm doing is I'm getting PowerShell to connect to Azure using the managed identity of the Azure function. Yeah, and then the run.ps1. So if we go into the HTTP trigger and we click on run.ps1, it's exactly as I showed. This is essentially the meat of your Azure function. This is the execution script that will run. So let's just say we've been developing this locally. So in order to do that, click on Azure. We can see down here we've got our workspace. So notice that I haven't signed into Azure at all here, but under local functions, we can see our functions, and then we can kind of see a local functions app, and then we can see our functions underneath that. So if we click on that, we can copy the function, execute, disable, or add binding. So if we wanted to add a new one, we would essentially right click here and we could go create function. So this is the function VS Code extension that I was telling you about earlier, and the cool tools. So if we go create function, we can specify the trigger that we need or that we're working on. So as I alluded to earlier, we can trigger the function based on HTTP, timer triggers, Azure Blob Storage trigger, so adding and removing a file from an Azure storage account. Azure Blob Storage is an example. Cosmos DB, we've got our durable functions. We've got our storage trigger again, but using Event Grid. We've got normal Event Grid, Event Hub, IoT Hub, Azure Queue Storage Trigger, which is what we're going to use in the second demo, SendGrid, and Service Bus triggers as well. So if we just click on HTTP trigger, we can give it a name. So I've already got HTTP trigger 1 already defined. So we're going to just specify HTTP trigger 2. So this is the name of your function that runs within the function app. And then we can set the authorization level. I'm just going to stick with function. And then it's created the files that we need here. Sorry, it's just gone out of full screen for me. So if we go into here, we can go into the Explorer. We should be able to see the HTTP function 2, and then we can see our function.json file. So that's our bindings in and out. So we can see we've got a HTTP trigger in with the name of request, and then the methods it supports are get and post, and then the response is going out as well. So this is really where we can start getting going. So it's given us an example HTTP trigger template to work from, and we can see here that we've got our trigger metadata and our request. So if we go back to the Azure toggle here, and then we go HTTP, we'll just get rid of that by just disabling that function because I only went through to show you, but we've got a HTTP trigger 1 here, which is very similar to exactly what we've just created actually. So if we go to copy function URL, we can see that it's given us a function URL of HTTP localhost 7071 API HTTP trigger 1. If we can see our ports, we can see we've already opened up 7071 through the GitHub code space alluded to. But if we click on this, it's not working. So in order to get that to go, we need to actually execute the cool tools to be able to run our functions. So let's go into that. So in order to do that, what I've done is I've created something called a REST book. So this is very similar to a like a Jupyter or a Polyglot notebook where you can actually run PowerShell commands and .NET commands locally within a workbook style environment. But this one, REST book, is essentially just for REST API calls. So we can see we've got our HTTP trigger 1, and then we're going to pass it a name for Tony Stark. So if we run that, that will fail because we're not listening. We don't have the cool tools, essentially the function at runtime running. So let's run that. So within the README file, I've actually just got function start. So essentially before we can run or debug the functions in this project, we need to start the function hosts from the root directory, which enables the triggers and the ability to do this development. If you were just pushing your function apps directly into Azure, you don't need to do this, but because in this case we want to be able to test our HTTP trigger function locally, as in within the code space, we want to be able to run our function runtimes. So we're going to go to terminal and we're going to actually start our function. So that's going to run our function called tools. And as you can see, it's missing the local.settings.json file that I talked about earlier. This is required for all triggers other than the HTTP trigger, which we're going to be used, RabbitMQ, activity true. So as you can actually allude to, like the RabbitMQ trigger, so the RabbitMQ or the orchestrator or activity triggers, none of these were actually part of the templates that we were able to deploy from a new Azure function. So there's a lot more triggers that you can do than the ones out of the box. So make sure you refer to the latest Microsoft Learn documentation about that. So now that the core tools is running, we should be able to see, if we go into Azure Functions, if we go to Output, we can actually see the Azure Functions listed here. We can see that we've disabled the function. So if we go in back here and we go to execute function, and then we send it the name. So this is the JSON name query, and we're just going to use the default of Azure here. We can see that it failed to connect, and I wonder if that's due to the local, but let's go back to our runbook. Let's see, function start. Okay, Demagogue's out with me today. I will come back to you shortly. Right, I've been able to fix this temporarily by creating the local.settings.json file and then adding in the Azure Web Job Storage value here with just remove just enough to just keep it going. So once that's done, I've reran the function start again, and it's complained about. Sorry, the function start here, and it's running and it's complaining about the second demo. So the create RG function that we're going to use in the second demo, it's complaining about missing the connection strings and settings for that. So I'm going to sort that out before the next demo. However, we can see that the core tools is running. So if we go to out and we go back to Azure Functions again, let's take a look. So if we go here and then go to execute function now and give it the name Azure request body again, if we submit that, we can actually see it executed successfully by responding, hello Azure, this HTTP request executed successfully. So what that means is that within the HTTP trigger and the run, we can see that we actually processed this HTTP trigger function executed successfully by the name, added it to the body variable, and that's passed out. So keep in mind a couple of things I wanted to point out here is even though we've got right host, HTTP trigger function processed a request, we can see in the output that that actually wasn't true, because what I mean by that, it wasn't passed through, because that was never passed through to the body variable that was outputted in our output binding. So keep in mind, you can have like things like error loggings, you can have output to host, which may be stored in the logs of the Azure Functions or write output, but it may not, you may not necessarily need it in the output binding as well. So keep in mind when you see some of the stuff not passing through correctly, like for example, we actually might have wanted the PowerShell HTTP figure processed a request. But because that's not part of the body variable and that was not pushed out of the output binding, we never saw it. But now that the core tools is running, if we go back here again and we've refreshed this, we can actually see that our function apps runtime is running. So exactly how you would go to the Azure portal and browse your functions, like is the runtime actually working? We can see here that this is actually running directly from our GitHub code space and authenticated as such. So we can do the exact same thing. So if we go into the terminal, and we grab the information here. So example, it's /API/HTTP trigger 1. We can see that the trigger executed. However, we didn't pass it a query string in the request body. So we're going to go in and create that. So if we go into our runbook, we're going to just quickly take this. And we can see that the function app is running locally, and we can query it by using a HTTP trigger. So by giving it the function app name, HTTP trigger 1, and then giving it the query. So example, the request body, the request information is going to be name, and then equals Tony Stark. And exactly the same app, but hello, Tony Stark, this HTTP trigger executed successfully. So we can test this using the public browser as well. Now, last thing I'm going to show you is, remember how we went to the REST book and then it tried looking up locally on 7071 and failed because we had issues with the function app local core tools actually running. If we run this again, we can see that we've got the 200 response, so it's been successful, and the output locally as well. So Tony Stark to the Hulk, exactly the same thing. So that's running out and executing our HTTP trigger PowerShell function locally within the code space successfully. So hopefully this has given you a very quick demo of how you can build and test your functions locally or within an Azure or GitHub code space to help you really start to build out that capability without actually needing anything deployed into Azure. So let's continue on with the rest of the presentation. So we haven't prayed to the demo gods today, but we're just going to go ahead with it anyway, and we'll see where we end up. So we've talked about deploying our function app locally. In my example, I was using a GitHub code space. We talked a bit about the core tools, publishing 7071 port via the code space and testing that locally with the REST book. Now we're going to talk about actually deploying our application, our Azure function, into Azure, and how we can do that from the same user experience using Visual Studio Code. We're also going to talk about some of the configuration within the function app in the Azure portal and how to manage the resources. So exactly the same thing. In this example, we're going to be talking about, actually, we have a new message that is sent to an Azure Storage queue. In my example, it's just going to be JSON output with the name, and then that will, once that's added to the storage queue, so that could be, in my example, I'm just going to be adding it manually within the Azure portal. However, you could have a third-party solution or system just adding to that queue constantly. So it could be another PowerShell script or function. It could be another system that allows you to add to a queue or a message type, and then the function will be triggered based on that queue input. And then the Azure function will then actually authenticate to Azure using the managed service identity of the PowerShell function app. And it's going to create our resource group and our storage account for us based on the input that we provided within the storage queue. So I just want to recap some of the things that we went through just as a reminder. So the host.json file, this contains the global configuration options that affect all your functions within that function app. It includes the settings for logging, extension bundles, managed dependencies, and concurrency. Then you've got your local settings.json file, which is used to store your application settings, connection strings, and other settings that might be used by your function app. When running locally, it's not deployed to Azure, but as we found out, just be very mindful about how you're committing that to your Git repo, for example, because in my example, I lost my local.settings because I was running it completely from the code space, which was committed into the Git repo, but it was ignored from being committed. So I lost that file. And now, in preparation for the next demo, I'm going to go through and recreate it for us. And then we've got our profile.json file, just exactly how you would be running PowerShell locally on your own endpoint device. It's executed every time when the function app has a cold start. It can be used to find your helper functions, run commands, or specify any environment variables that you have. It includes the code to authenticate with Azure using the managed service identity or any other mechanism that you may want. And then you've got your requirements.ps1 file, which specifies the PowerShell modules that your function app depends on. And the Azure Functions runtime will automatically install these modules when your function app starts. And then we've got the meat of it, which is the run.ps1 file. So this is the PowerShell script that contains the code that runs when your function is triggered. So let's get into another demo and see how we end up about deploying our Azure function and testing it into Azure. So now we're going to go into our second demo, and that will be deploying a function to Azure, to a function app, and then actually going through and testing it. So the function app we're going to deploy today is the create RG function app. So we've got our functions.json. So that's the input binding, which is going to be, which is called queue item. It's of type queue trigger. And then the queue name and the connection that we're going to use. So I'm going to explain a bit more about the connection shortly, but essentially what we're saying here is we're going to have a trigger based on Azure Storage queue. We're going to add a message to that queue. That function app will then pick up that trigger based on the connection and the queue name that it is in as well. So I've got an Azure Storage account, which has RG create, and then the connection is going to be storage count queue create. So if we have a look in the Azure portal, and then we go to storage accounts, we can see we've got a storage account here called STG SKU 1337. So if we click on that, and then we navigate down to queues, we can see we've got a queue that's called rg-queue-create, but that could be any name that matches what you're wanting to do within the message queue. So within this queue, we've got nothing because we haven't added a message and we haven't deployed the function app yet. So, but this is really the name of the queue, and we can see it's matching up here. But how do you know what storage account this queue is located? And that's where the connection comes into play. So within the run file, like the run.ps file, we can see we've got the actual PowerShell script that's doing what we want. So we've got our queue item. So that queue item is coming from the input binding. So that's our Azure Storage Account queue. So we're taking the input there. We're then going to output a lot of information to the host. We're also going to grab that queue item and then put it into a config variable. And within that config variable will be the information that we're going to be including in the queue, which is a storage account name and a resource group name. Then we're going to, because in this example, we're going to be putting in a message to the storage account queue, which will then create an Azure resource group for us and a storage account. We might need things like the name of it. And because we're creating a resource group, we may want to prefix some information that might be aligned to organization naming standards, such as RG-, for example. So we're going to grab the name of the storage account and the resource group based on the inputs that we're going to give it. And then we're going to write that host. So we're going to write it to essentially the log of the function app. We're going to set the location. So I'm based in New Zealand. And at the time of this video, Australia East is the closest region to us, where New Zealand North region is coming in December, which I'm looking forward to, but Australia is the closest region to me. So that's usually the default location. And then I've got some PowerShell here, and as you can kind of see, it aligns to the normal commandlets that you would be using normally. So this is essentially just a PowerShell script that allows us to do this. So we've got our resource group. So in this example, I'm going to get a current resource group based on the name that I've sent the message. Does it already exist? If it doesn't already exist, then we're going to create a new resource group. Now, the next thing that we want to do is within that resource group that we've created is create an Azure storage account. So there's a commandlet called get AZ storage account name availability. So storage account name needs to be globally unique. So if we're trying to deploy a storage account that name is already in use, we want it to check it. And if the storage account name is available so we can create it, it will actually go through and create our storage account for us. If the name is not available, then it's going to come back with an error to us saying the storage account is not available. Please choose a different name. And then, yeah, that's essentially the meat of the function. So in order to deploy it, we go to Azure, and then we go up here to Azure Functions. No, we don't. We go to right-click the local project, and we select Deploy to Azure. We've not signed into Azure yet, so we're going to go up here to sign into Azure. The extension Azure Resources wants to sign in using Microsoft. We're going to allow that. That's going to take us to the logon page. We're going to sign into our Azure environment. It's going to sign in. Once it's signed in, we should see a list of essentially the subscriptions and the resources that we have access to. We can now then go to deploy to Azure. And then we can see where do we want to deploy our function app to. So in my example, I'm going to select my Visual Studio subscription. And then if I don't already have the function app, I can create a new function app. In my example, in my demo, I've already got a function app created, and there's a reason for that. Because in this example, I'm doing things like creating an Azure storage account based on the queue message. I needed to set up the system managed identity of the function app and give it the permissions in order to create those resources within Azure. Now I'm going to show you that in the Azure portal, but I've done that ahead of time just to show you. But what we're going to do is essentially overwrite the code that's in there with what we've deployed within the GitHub code space. So we're going to select function apps Luck. That will then load the deployment configuration and bring that in, do some validations, and then prompt, do you want to deploy to this function app? This will overwrite any previous deployments and cannot be undone. So this is the message you get if you're trying to deploy to a function app that already exists. And in this case, we're going to click deploy. So just keep in mind that when you're deploying through the Visual Studio Code method, this is really good for testing and developing your functions within Azure. But when you're looking at working with multiple teams, multiple people, more production-based scenarios, you will need to look at things like continuous integration, continuous deployment, and essentially the repository that you're working at, you may want to include things like pesta tests and other things where you would automatically commit to the repository with the latest version of the code, and then that will go and trigger, like, for example, a GitHub Actions or Azure DevOps pipeline, run branch policy tests, and then deploy to production as well. This is not part of the demo that I'm going to show you today. It's more about locally developing and getting started with Azure Functions, but definitely take a look at the continuous integration and continuous deployment options of Azure Functions, because there's a lot in there and you can do a lot with Azure DevOps pipelines, for example, when going into production. But we want to overwrite everything that we've already got, so we're going to click deploy. And so that's going to deploy our create RG and our HTTP trigger function app into Azure for us. We can see here it's within the Azure, it's deploying our zip, it's zipping up the packages and deploying it, running the build. So we'll wait for this to complete. And we can see it's succeeded. So within VS Code, we can actually look at the output and see what it's done. So it's added the run website from package because it's essentially zipping up and packaging to deploy the function app. And then it's adding the files that we've got in our repository into a zip package. So in this example, it's added the HTTP trigger 2 that we created earlier, the create RG functions, the function ignore, the host file. In this case, it's got the dev container files as well. But what I should actually go and do is go into the function ignore file and add in the .dev container folder as well. We don't want to deploy any of our dev containers files into the Azure function. We want it as lean as possible. Once that's all zipped up, it's updating submodules, preparing the deployment, and then essentially uploading the zip file into Azure, and then syncing and overwriting the triggers. Now, if we go into the Azure portal and we go to our function apps, we can see that I've got a function app running. So if we click on the function app, we can see that this is the function app that I've deployed to. So if I click on browse, I can see almost the exact same UI response that we got when we were running the Azure Function core tools locally within the GitHub code space as well. But in this case, we're actually working from Azure directly. If we go under our identity, this is what I was telling you about earlier. So this function app was created ahead of time, mainly because by default, the system managed identity is not created. So I've gone in here and I've toggled it to yes, and then I've gone into Azure role assignments, and then I've actually specified for our example that this function app's system managed identity has storage queue data contributor to the storage account, because we want it to be able to read the essentially the data from the storage account from the queue, and then contributor rights to the subscription as well, because we want to give the function app the ability to create our resource group and create our storage account. Of course, in both these examples, use the least privileged account that you need. You can create custom RBAC roles to do the exact tasks that you need to do. So just bear that in mind. And you can always test with less privileged roles and then work your way up as you go. But these are the settings that I needed to do ahead of time. So if we go into our environment variables within the function app, we can see our app settings. So this is mimicking essentially what you would have in your local.settings JSON file. We can see because we went in here earlier and we actually disabled our HTTP trigger to function, we can see that that's gone through and disabled that trigger in here. Actually, that's something different, but it's gone in and disabled it. So disabled equals 1. So yes, it's disabled. If we change that to 0, for example, it would all delete that. That would enable trigger the other trigger. Now, when I was talking about the connections earlier, so if we go into Q and we go in here and go into here and then our function.json file, we can see here that we've got a connection name of stg stew account. So it's supposed to be storage queue account. So how does it know what storage account and queue that is talking to? So when using a storage account queue, what you can do within the function app is that you set a variable which is storage queue account. So this part of it is the name of your connection. So it needs to you need to make sure that storage queue account matches the connection name. And then we've got 2 underscores here referencing the queue service URI variable. And the value for this setting is the endpoint of the queue that we're connecting to. So if we go back over to our storage account that we have our storage account queue under, so if we go to storage accounts, and then we go into our storage account queue, and then we go to, should believe it's under endpoints or queue endpoints, we can see here that our endpoint for our queue service is https stgq1337.q.core.windows.net. So we want to grab this endpoint URI and we want to feed that into here. So this would be exactly the same setting that I would have in my local settings JSON file as well if I was testing this locally, but that's set up in the application setting of the storage account. And then if we go into our, so for example, this was deployed into a Windows operating system with the app service plan with the runtime version. So that will correspond with the runtime version that we've set up in our host.json file. So we want the extension bundle of our host to be one of the latest versions of 4, for example. So if we go into our function app, we can see our runtime version is 4.34, and then our app service plan by default is a Windows operating system with a Y1 pricing plan as well. So we can now upgrade or change this plan as it suits our function needs. So if we go back to our function app, we can go to our application files, so within our functions, and we can see our host.json file. We can see our profile.ps1 file, which matches exactly what we had in our Git repository. Our requirements file, exactly the same. Our function ignore file. So these are the files from a host perspective. So you have your function app, and then you've got your functions that run within that function app. Exactly the same thing as what you'd think about when you consider a Azure App Service as an example. You've got your Azure App Service plan and then your apps running underneath that plan as well. So the more functions you have within the function app, the more it shares the very similar infrastructure. But that goes back to the scale controller that we talked about earlier. So we've talked about identities. We've talked about the files that we can see here from the function app perspective. What about our apps themselves? So let's go into that. So in order to go and have a look at our functions that we've deployed, we go into the overview pane. We navigate here down to functions, and we can see the functions that we've deployed. So we've got our HTTP trigger function. This is the function that we tested in the earlier demo. We can actually we can see the files here. So if I just try to collapse that, we can see that there's essentially the run.ps1 file. We can see all the associated files, so the function.json file, which would determine our input trigger and any bindings that we might have. And we can test this. So if you were to test your function apps locally within the Azure portal, you could use a test and run. And in this example, the query that we have set up is just name. So we're just going to go, the name is going to be test name, and we're going to give it Dr. Strange. I'm going to run that. One thing I want to point out as well is when you run within and so that's outputted 200 response, and then hello, Dr. Strange, this HTTP trigger functions successfully. So now we're running it from the Azure platform, not locally using the function app core tools like we did earlier. One thing's pointing out is when you're in the code and test pane, you can see the logs here that are running and being outputted by application insights. And you can see in this example that it's executed the HTTP trigger. It was called parametrically via the host APIs. Essentially, that's because we went into the test and run, and that's why it was called. And then it started to run the function app, and the output of the function app was processed, and we can see that here. This will reveal the logs essentially as part of our testing. If we go into logs over here, this is the logs that we would see if we were to run the function outside of that code plus test as well. So when you're starting to test and look at what's happening within your function, make sure you check out the logs pane. You can also see the metrics and the invocations as well, like how many times has it ran, how many times has it ran from a success perspective. And it could take, the results may be delayed for up to 5 minutes to appear in here. So you can see the success and errors of the invocations. The invocations is essentially the run point of that. So if we go back to our Azure function and we go down to our create GQ, we can see exactly the same thing. So we can see our code, our function.json file here. We can see the information. We can see the README, everything we've essentially just deployed from the Git repo. So let's test this. And we can see that here's our queue and our trigger queue item and trigger metadata. So let's test this. So I'm going to go to logs. That will connect to the application insights instance and then bring up the logs. Then I'm going to go back to the code space that I had. Then I'm going to go to the REST book. And I'm not, maybe I'll put it into the README. Yep, here it is. So this is the queue information that I'm going to pump into the Azure Storage Queue. So it's just JSON referencing the storage account name, and we're going to give it a value. in this case, it's just SDS and then the resource group name, which is ASD AS. So these are just um, random values essentially that I've just manually created. But keep in mind for your purposes, they need to match what you have from an organization perspective. But these were just randomly generated names to make sure that the storage account name was unique for the purposes of this demo. So if I go to our storage account and then I go to our queue, so under data storage, I go to queues and then I click on RGQ create. I go add message. The message we're going to add is storage account name, resource group name. As with most queues, we can set it to most messages. We can set it to expire, so we can have it expire in seconds, minutes, hours, and days. Well, I'm just for the purposes of this, and never expire, but I'm just going to set it to expire in 7 minutes. And then there should, I go down, there we are. We can encode, sorry, it's just we're going to specify encode the message body in base 64 as default, and then just click OK. So that's added the message to the message queue. We can see the insertion time and the expiration date based on what we set, and the DQ count, so when it was removed from the queue. If we keep refreshing that, we can see that actually the Azure function has now picked up that queue and it's been removed from the queue automatically. So we can see here that the functions create G has ran based on a new queue message, which was detected on our RGQ create storage account queue. It's then the PowerShell queue trigger has then processed it. We can see and marked the DQ count as 1. We can see that the JSON body that we've supplied, so the storage account name and the resource group name, we can see that the function has automatically imported our modules from the requirements.ps1 file. We've also given it an output. So for example, in this case, it's actually creating the resource group name for us in the Australia East region, and then outputted the subscription name. It's also told us that the storage account name SG is not available. Please choose a different name. So in that example, we essentially need to do the exact same thing. So what should I put it as? This is how we roll. Just make stuff up and then click OK, and it should process the exact same. Again, this is exactly what you would be doing in any script or any queue that you want it to be. In this example, this was the easiest thing I could find to test. We can see that it's now picked up that message and the function app is running. And in this example, because I didn't change the resource group name, it's already used the exact same resource group that we created earlier, and now it's running the new AZ storage account module. So if we go in to create that storage account for us, so if we go back to the Azure portal again, and then we can see it's executed successfully. So if we go back to our Azure portal again into resource groups, and then we go in to search for that resource group, we can see that it's been created and our storage account has just been created as well, based on the message that we've just given in the Azure storage account queue. So hopefully that's given you a clear and useful demonstration of developing Azure Functions with PowerShell. So we've gone through sort of how the functions work from the scale controllers, the execution. We've discussed triggers and bindings. We've gone through a demo on HTTP request and how we can test that locally with Azure Functions called tools, and in my example, GitHub Codespace. We've also gone through how we could use a queue trigger. So in this example, we use an Azure Storage queue to trigger the creation of Azure Resource Group and a storage account. So the mind boggles at things like how you can use Azure Functions with storage queues for things like self-service automation and all sorts of other things as well. Hopefully I've given you a rundown on how the different files work. So the host.json file, the local settings file, the run.ps1 file, the requirements file, they all work together to really give you that execution serverless environment that you need to run your code. So there's some great Microsoft Learning modules for Azure Functions, some great web pages. I'll put those in the links to the comments as well. And yeah, some great sessions that are happening across Azure Back to School. So make sure you check those out. I just want to end by giving you kind of a bit more information. So, Azure Functions is an open source project. All the functions runtime and all the extensions are fully open sourced. Azure Functions Core Tools lets you develop and test your functions on your local computer from the command prompt or terminal, and local functions can also connect to live Azure services as well. You can find more information about the Azure Functions runtimes at github.com/Azure/Azure-functions. If you've got any issues or you want to contribute to anything that needs to be better, even documentation, make sure you check out that GitHub link. You can open up a pull request, you can raise an issue. It's really about the community helping the community with this capability. I'm just going to end on a few notes about architecting for Azure. So, and also Azure Function hosting options. So I didn't really talk much about sort of the price plans on Azure Functions, and that was on purpose because I wanted to keep it at an end. Again, it depends on your use cases and what you're wanting to use it for, but there is flexibility. So for consumption plan, you pay only for what you use. Charges are applied per execution and per gigabyte every second. For the premium plan, you get the best of both serverless and dedicated hosting. You can leverage fast dynamic scale while benefiting from consistent performance, which helps to avoid those cold start, network isolation, and it's more predictable costs. When you run with an app service plan, it runs your functions on the same resources you've already dedicated for web apps, such as an app service plan. So in our example today, we actually deployed it out of the box by default to an app service plan. Then you can also run your functions on Kubernetes as well. And that adds things like event-driven autoscaling and triggers to your Kubernetes cluster by hosting your serverless containers. And you can use event-driven triggers such as CADA. So Kubernetes event-driven autoscaler. So that's really useful when the normal default triggers that you may get from an Azure function may not suit your need. So CADA with CADA support through Kubernetes opens up a realm of possibilities and third-party triggers that you can use to help really drive yours. You can also run your Azure functions on Azure Stack, so you can bring the power of those serverless functions to your own data centers. You can also run your Azure functions on IoT Edge as well, so you can deploy custom Azure Monitor on IoT devices. So Azure Functions enables you to build, once you deploy it, to multiple destinations. Again, app service plan to run your functions in dedicated compute. Elastic Premium plan you can use for consistent performance, avoiding cold start. You can deploy on flex consumption plan for the best in-class high performance throughput and network capabilities to scale to zero for serverless options. You can also open source function images and host them on Kubernetes, AKS, or IoT edge devices. You can also run functions on Azure Container Apps as well. So use Azure Functions Flex Consumption Plan when you have the following situations. Your function requires fast scaling and high throughput. You want to pay as you go, but with networking features. And you want control over concurrency-based scaling, which also includes HTTP. Use Azure Function Premium Plan in the following situation. You want your Azure Function apps to run continuously or nearly continuously. You have a high number of executions, you have a small number of execution, but a high execution bill, but low gigabytes per second. You might need larger CPU or memory options. Multiple function apps can run per plan for optimal usage of compute, which really aligns to that sustainability story as well. And you have dependencies on Windows like .NET Framework or Windows APIs as well. You can consider an app service plan when you have existing underutilized app service instances that are already running web apps. So you can co-locate web apps and function apps on the same plan. You also have dependency on Windows like .NET Framework or Windows API. You want predictive scaling and costs as required, and you require large compute and memory options. You can run your functions within Container Apps environment at regular Container App rates, which is best for building a solution that requires both containers and functions. You should consider container apps when you have the following situations. Your solution requires containers and functions to work seamlessly together. You want to leverage common networking, logging for all your apps within the container app environment. And you want to integrate with Dapper for service to end-to-end calls and other integration scenarios between microservices. So let's talk about considerations for architecting for Azure. So this is very high level, but you follow the same guidelines according to the well-architected. So reliability, make sure that your workload meets the uptime and recovery targets by building redundancy and resiliency at scale. When you consider security, it's really about protecting your workload from attacks by maintaining confidentiality and data integrity. Cost optimization, you need to adopt a cost optimization mindset when building these Azure functions at an organization, architect, and tactical level to help spending within your budgets. That's where things like FinOps come into play as well. Of course, operational excellence. Reduce the issues in production by building holistic observability and automated systems. You've got your performance efficiency, so you need to adjust changes in demand based on the workload through horizontal scaling and testing changes before deploying to production. So this is the well-architected framework for Azure, but when you're building out your Azure functions as well, these are very key to keep in mind. Reliability, security, cost optimization, operational excellence, and performance efficiency. And you can find a lot more information in the well-architected framework and the cloud adoption framework as well. If you're looking for examples of potentially messaging options and how other people have done it, the Azure Architecture Center is a great place to start. It's got example diagrams, example trade-off and considerations when architecting solutions for Azure. This guidance is not just specific to Azure Functions, it includes everything within Azure. So, yeah, hopefully you've had fun. I need some water, been talking a bit, but go and build, go and test, learn, play. Let me know how you get on. Thank you very much and have a great rest of Azure Back to School.